Okay, we're going to look at something called exact values, which is the starting point for our trigonometry work. Okay, so I'm going to just launch straight into this. Let's imagine that we had a triangle as so. So it's a right angle triangle and it's also an isosceles triangle, meaning that both of those sides are the same length. Let's say that this length was 1 and this length is 1. Let's say I was to call that side x. Well, by Pythagoras then, x squared would be equal to 1 squared plus 1 squared, x squared would be equal to 2, and x would be equal to root 2. So what we can say then is that the exact value of the hypotenuse there is root 2. Now, next thing that I can say is, if this is an isosceles right angle triangle, that means that both of these angles need to be the same. Now we know that 3 angles in a triangle add up to 180 degrees, and we know that this is 90 degrees, so these two must add up to 90, and if they're both the same, that means both of those angles must be 45 degrees. Okay. Now what that allows me to do next is to start working out my first 3 exact values. Now what does that mean? Well, let's concentrate on this angle here, and that's the one that we're paying attention to. Well, in that case, then this would be the opposite. This would be the hypotenuse, and this would be the adjacent, thinking about SOHCAHTOA. So, if you think about the SO bit, sine 45 then would be equal to the opposite over the hypotenuse. Well, what's the opposite? Well, you can see clearly the opposite is 1. And what's the hypotenuse? You can see clearly that is root 2. Therefore, sine 45 is 1 over root 2. Let's now try cos 45. Well, remember for SOHCAHTOA, it's SOHCAH. So cos is adjacent over hypotenuse, so cos 45 will be equal to the adjacent over the hypotenuse. So what's the adjacent? Adjacent's 1. What's the hypotenuse? Well, it's root 2 again, 1 over root 2. Okay, so now I've got sine 45 equals 1 over root 2 and cos 45 equals 1 over root 2. Let's now look at tan 45. Well, tan 45 would be opposite over adjacent. So what's the opposite? Well, as we can see, there's the opposite again. So it's 1 over the adjacent, which is 1. 1 over 1 is 1. So that gives me my first 3 exact values. I've got another 12 to get. Sine 45 equals 1 over root 2, cos 45 equals 1 over root 2, and tan 45 is equal to 1. Now, the point of the thing is we need to remember those exact values. You're not given them in the exam. There's 15 of them that you need to remember, and the first 3 are sine 45, cos 45, tan 45. Sine 45 is 1 over root 2. Cos 45 is 1 over root 2 and tan 45 is equal to 1, and we call that a special triangle. Now we're going to get some more exact values from a second triangle. Okay, here's a second triangle then. Right, so this time we've got to start with an equilateral triangle, meaning that the 3 lengths are all the same. So that's 2, and that's 2. That means then that would be 60 degrees, 60 degrees, and 60 degrees, because 3 angles would need to be the same. They also need to add up to 180, and that 3 times would be 60 degrees. What I'm now going to do is split this down the middle. Okay, and I'm going to extract that new triangle that I've created within the bigger triangle and draw that out again. Okay, now what you can see then is that 60 degrees has been split down the middle, so that would now be 30 degrees. That's a right angle if it's been cut like that, and that's still 60 degrees. That's still 2, and I've halved 2 down there to get this bit here, which would be 1. I'm going to call that y, and I'm going to work out y. Now y is a shorter side, so for subtraction, for Pythagoras, that will be to subtract. So y squared will be equal to 2 squared minus 1 squared. Y squared will be equal to 4 minus 1, y squared is equal to 3, and y is equal to root 3. Okay, so now I'm going to go after sine 30. So sine 30 is equal to opposite over hypotenuse. So there's 30 opposite over hypotenuse, 1 over 2. What about cos 30? Cos 30 is going to be adjacent over hypotenuse, root 3 over 2. That's just simple SOHCAHTOA, remember. What about tan 30? Tan 30 then is going to be opposite over adjacent. So that is opposite over adjacent, 1 over 2. Okay, let's now try and get sine 60. Sine 60, well, there's 60, opposite over hypotenuse, root 3 over 2. Cos 60, cos 60, adjacent over hypotenuse, 1 over 2. And then what about tan 60? Well, tan 60, opposite over adjacent, so opposite over adjacent, root 3 over 1, root 3 over 1 is just root 3. Okay, so as I said previously, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11, 12, 13, 14, 15 exact values to get. Okay, so we've got 9 of them. Okay, so the first one, sine 45, well, that was 1 over root 2. And then cos 45 was 1 over root 2. And then tan 45 was equal to 1. We then found the 30s, so sine 30 was 1 over 2, cos 30 was root 3 over 2, and tan 30 was 1 over 2. Okay, then we found the 60s, so sine 60 was root 3 over 2, cos 60 was 1 over 2, and tan 60 was root 3. Okay, so we've got another 6 to get. We've got 9 of those from the two triangles, that one and that one. We're going to now get sine, cos and tan of 0 and sine, cos and tan of 90. Now, next we're going to gather the last 6 exact values from the graphs of y equals sine of x, y equals cos of x, and y equals tan of x. And these are not new to you. You've seen these in National 5. Okay, so sine of 0, well, if we go with the sine curve at 0, we can see that that curves at 0, so sine 0 is equal to 0. Cos 0, well, that's up at 1, so cos 0 is 1. And then tan 0, well, tan 0 occurs at 0, tan 0 is equal to 0. Okay. Let's now go after sine 90. Okay, sine 90, so I go along to 90, travel up, and that is equal to 1. Cos of 90, I'll travel along to 90, and that's at 0. Okay, tan 90, let's just unpack this one a wee bit. Okay, now that might look as if I'm about to say that's 1. Okay, now, if you were to put in tan 89 into your calculator, then now you would get about 57.1. If you then put in tan 89.9999 in, you would get 57,000 and odd. Okay, so in theory, if we get close enough to 90, if we get to 90, what we say is that is an infinite result, so that's undefined. If you go ahead and put that in your calculator now, tan 90, in your own degrees mode in your calculator, which is the D on the front screen. If you put in tan 90, you should find that you get undefined. Another word for that is infinite, but in higher maths we call that an undefined result. Okay, so we can start to put them into the table then. So, sine 0 is 0, cos 0 is 1, and tan 0 is 0. Sine 90 is 1, cos 0 is 0, and tan 0 is undefined. Okay, now I've spent almost 10 minutes establishing these 15 exact values. Now, the main thing is you just need to know them. So you need to get to know these off by heart, just like your times tables. So you will be expected to be able to quote each one of these exact values. If somebody was to say to you what's sine 60, you can immediately just say it's root 3 over 2. What's tan 45, it's 1. What's sine 90 is 1. So you need to be able to automatically recall those 15 exact values. Okay, they will come up in a non-calculator paper. There will be no access to go to your calculator. If you go to your calculator just now and put, for example, sine 30 in, the calculator will give you a result of 1/2, 0.5. But the point being is that it will come up in a non-calculator paper, and you really just need to take the time and put the work in to remember every single one of these exact values. Okay, now a requirement of us really is that we can find any exact value that lies between 0 and 360 for sine, cos and tan, even though, as you can see, we've only been provided with exact values between 0 and 90, and even extending beyond that. So beyond that in the negative direction and beyond that in the positive direction. What does that mean and how are we going to do that? Let's have a go just now. Okay, so let's say, for example, that I wanted to find sine 135. Now if we go to sine and we go up to these numbers here, that doesn't appear to be here, but we can still get it, and we're going to get it by using this diagram and using the cast diagram from National 5. So let's just try a few examples and get this pattern going. Okay, so sine 135. Okay, now the first thing is start recalling the cast diagram, which is so. So it turns anti-clockwise, 0, 90, 180, 270 and 360. Okay, so what I'm going to do now is draw in 135 degrees as a turn. So we're going anti-clockwise, there's a 90-degree turn, and there is 135 degrees. I'm now going to draw a line up. Okay. Now, because we're in the sine quadrant, that means that this result, sine 135, is going to be a positive result. So just go with me with this one just now. So it's going to be positive sine. Now our next move then, this is just a trick, is we get this acute angle in here. Now the acute angle in there, well, if that is a turn of 135 degrees, the acute angle there to take you to 180 must be 45 degrees. Okay, and then plus sine 45, go up to our diagram, and there you can see it. Sine 45 is equal to 1 over root 2. And that is how you solve that one. Okay, let's go through it again. So, sine 135, first I'll get the cast diagram, do your 135 degree turn, we'll line in the sine quadrant. Sine is positive in the sine quadrant, so let's put a positive sign. Find the small acute angle here, which is 45 degrees, sine 45, lift it from the table, 1 over root 2. Okay, let's try a second example then. So, a second example, let's go for, let's bring the table back into view. Okay, so let's this time go for cos 225 degrees. Okay, let's get the cast diagram going. 0, 90, 180, 270, 360, and let's draw in 225 degrees. So there's 0, 90, 180, 225. We're in the tan quadrant. Okay, first thing that I would say is we're in the tan quadrant. Cos is negative in the tan quadrant, so it's going to be minus cos. Now what's this small angle in here? Well, we've moved from 180 to 225. That's 45 degrees minus cos 45. Go up to your diagram. There it is there. So cos 45 is 1 over root 2, so minus cos 45 must be then minus 1 over root 2. Okay, let's try another. Let's go for tan 315. Okay, let's get the cast diagram. 90, 180, 270, 315 degrees. Okay, first thing, we're in the cosine quadrant, so tan is negative in the cosine quadrant. Then I go for my acute angle. There's my acute angle there, and it's 45 degrees minus tan 45. Back to the table, tan 45 is 1, therefore it's minus 1. Let's try another one. Let's this time go for cos 225. Okay, cast diagram again. 0, 90, 180, 270, 360. Okay, 225, there's 90, 180, 225. Okay, the acute angle then is 45 degrees. We're in the tan quadrant, cos is negative in the tan quadrant, so it's minus cos 45. Cos 45 is 1 over root 2, so it's minus 1 over root 2. Okay, next one. Let's go tan 210. Draw a diagram every time. 0, 90, 180, 270 and 360. Okay, 90, 180, 210. Okay, so it's tan. We're in the tan quadrant, so it's positive. Tan is positive in the tan quadrant. My acute angle then is 30 degrees. Tan 30. Tan 30, go to the diagram, and that is 1 over 2. Okay, next one, let's go for sine 150. Okay, so 90, 150, the acute angle is 30 degrees. Sine is positive in the sine quadrant. The acute angle is 30 degrees. Sine 30, go to your table, sine 30 is 1/2. Okay, now you'll notice that I keep saying go to the table. That's for the moment just as you learn your exact values, but eventually when I say table I really mean you need to be retrieving that from your recall. Okay, next one, let's go for tan 330. Okay, so 0, 90, 180, 270, 360, 90, 180, 270, 330. Okay, we're in the cosine quadrant. Tan is negative in the cosine quadrant. My acute angle there is 30 degrees minus tan 30. Tan 30 then is 1 over root 3, so it's minus 1 over root 3. Okay, let's try one more. Let's go for cos 150. Let's cast diagram. Okay, so 0, 90, 150. We're in the sine quadrant. Cos is negative in the sine quadrant, so it's minus sine, and the acute angle then is 30 degrees minus sine 30. Sine 30 from the table is 1/2, so it's minus 1/2. Okay, and one more. Cos 330. Okay, 0, 90, 180, 270, 330. We're in the cosine quadrant. Cos is positive in the cosine quadrant, and the acute angle is 30 degrees. Cos 30 is root 3 over 2, so that's the final answer. Okay, we're now going to look at larger and smaller numbers that are out with the interval between 0 and 360 and see how we contend with that. Okay, now the first thing to remember, that again this isn't new to you, is the sine curve repeats itself after 360 degrees. So it's cyclical and it's got a period, and the period is 360 degrees. So that just means that it repeats the pattern after 360 degrees. So there is sine 30, and sine 30 is 1/2. So if I then count on 360 degrees, that would take me to sine 390, which would also have a value of 1/2 because it repeats itself and it holds the same value after 360 degrees. That's also true for the cosine function. It repeats itself after 360 degrees. Now the tan function actually repeats itself after 180 degrees, so its period is 180, 0, there you go, 180. And then it repeats itself again at 360, so it repeats itself after 180 degrees, whereas the cosine curve repeats after 360, and the sine curve repeats itself after 360. Okay, so let's say then that I was to ask you to find sine 570. Okay, the first thing that we need to do is try and get into this interval between 0 and 360. Now, since sine repeats itself after 360 degrees, that means sine 70 is the same as sine 570 take away 360. So that would then be the same as sine 210. So sine 570, if I move 360 degrees back, it will have the same value as sine 210, and that's because after that period of 360 degrees, the thing starts to repeat. Okay, which means if it starts to repeat, it holds the same value at that point. So sine 390 is the same as sine 30. Sine 570, take 360 off, that means that's got the same value as sine 210. They would be at the same point. Okay, and as soon as I get to sine 210, I can then go through the process of the cast diagram: 0, 90, 180, 270, 360, 210, 0, 90, 180, 210. Wherein the tan quadrant sign is negative in the tan quadrant, and my acute angle is 30 degrees minus sine 30, and that's minus 1/2. Let's try another one. Okay, this time let's go for tan 390. Well, we could take 180 off of that, and that will bring us to tan 210. They'll be the same. But I could then take another 180 off again to get within range, and that will bring me to tan 30, and I can just lift that straight from the table then. Tan 30 is 1/√3. Okay, what about cos 495? Okay, take 360 off to get within range, that's 0 to 360, and that will give me cos 135. Okay, as soon as I'm within range, 0 to 360, I can get the cast diagram. And there's 0 to 90, 135. Okay, I'm in the sine quadrant, cos is negative in the sine quadrant. My acute angle is 45 degrees, cos 45 in the table is 1/√2, so that's minus 1/√2. Okay, next one. Let's this time go for sine minus 120. Okay, so I want to get between 0 and 360, so add 360 on, that will bring me to sine 240. Okay, I'm within range, now I can get the cast diagram down. So 0, 90, 180, 240. 360. Okay, I'm in the tan quadrant, sine is negative in the tan quadrant, and the acute angle this time is 60 degrees. Minus sine 60, sine 60 is root 3 over 2, so that's minus root 3 over 2. Okay, next one, cos of minus 60. Cos repeats itself after 360 degrees, so I want to get within range, add 360 onto that, that's cos 300. Okay, cast diagram again. Zero to 90 to 180, 270, 300. Okay, I'm in the cosine quadrant, cos is positive in the cosine quadrant, and the acute angle there is 60 degrees. Cos of 60 is 1/2. Final answer. Okay, next one, sine 1020. Okay, I want to get in between 0 and 360, so what I need to do is this time take multiples of 360 off. So if I take 360 off, so let's do that now, 1020 take away 360. Okay, so that will bring me to 660. So I've got sine 660, now I'm still not within range, so what do I need to do? I need to take off another 360, and that will bring me to within range, which is now sine 300. And I'm in business with sine 300 because I'm between 0 and 360. Okay. Okay, so 0, 90, 180, 270, 300. Okay, the acute angle this time is 30 degrees, so that's, first of all, let me just make sure I get that right. Sine, we're in the cosine quadrant, so sine is negative, so it's negative sine. The acute angle is 30 degrees. Negative sine 30 minus 1/2.